Okay, so last question of the exercise, question 17. We've been told the group G with binary operation here is given, and we've been told that A is self-inverse, which means that A is equal to the inverse of A, and B is also self-inverse. We've also been told that the group is abelian. Okay, so commutativity holds. So A times by B is equal to B times by A. I'm just saying times because it's easier, but we all know that the binary operation could be any binary operation. So we've been asked to show that we've been asked to prove that AB is also self-inverse. Okay, so we want to show that AB is equal to inverse of AB. Okay. Alternatively, another way to show this is to show that, okay, so if we multiply both sides of this equation here by AB, we're going to get AB times by AB is equal to the identity element E. Okay, so that's the definition of an inverse. Okay, definition of an inverse is that if we take an element and times it by its inverse, you get the identity element E. Okay, so this is just another way to prove what we want. Okay, so what we can do now is we can, knowing that, we can multiply both sides of this equation by AB. Okay, so A times by B times by A times by B, and I'm not writing in brackets, of course, because I know this is a group, so associativity holds, so it doesn't matter which terms I kind of multiply first. Okay, so is equal to BA times by AB. Okay, and I know that the elements are self-inverse. Okay, so I know that I can essentially exchange this A for inverse of A. Will be exactly the same thing. Okay, so I can substitute A as inverse of A, and then again I can substitute B as inverse of B, and I know that A times by its inverse is equal to the identity element E. Okay, so I can get rid of these guys and say this is the same as having the identity element E here, and obviously the identity element E times by anything doesn't have an effect, so this is the same as B times by the inverse of B, and obviously that is the identity element as well. Okay, so right hand side boils down just to E, and here what I've done is I've shown that an AB times by AB is equal to the identity element. I could go a step further now, and I could multiply both sides by the inverse of AB. In fact, I'll do that now. So I'll just multiply both sides. Just multiply both sides in red by the inverse of AB, and this is equal to E times by the inverse of AB. Okay, and I know that any element times by its inverse is equal to the identity element, so the left hand side is going to whittle down to just A times B times by the identity element, which is the same as A times B, and this is equal to identity element times by the inverse, which is just going to be equal to the inverse. Okay, so this is equal to A times by B inverse. So I've shown that AB itself is self-inverse. Okay.